Another example of an application involving quadratic equations involves area. When we work with area, we often end up with squares, and quadratic equations have squares. Let's look at this one in particular. Each end of a glass prism is a triangle with a height that is 1 inch shorter than twice the base. If the area of the triangle is 6 square inches, how long are the base and the height? Well, in this particular problem, we're dealing with a geometric shape. I highly recommend, if you're dealing with a geometric shape, to go ahead and draw a picture. So we've got a triangle. So here's a triangle. Your picture doesn't have to be perfect, but just get a semblance of it in there. It has a height that is 1 inch shorter than twice the base. So if I call this the base and this the height that I drew here, one of the things it's saying is the height is 1 inch shorter than twice the base. Well, let's create some variables. It's telling us something about the height, but nothing about the base. So let's say the base is x. So I'm going to define that, and we're going to say let x be the base of the triangle. This is called defining your variable in words. We're actually writing out what we're going to let the variable represent. Since the base is x, then when I go back to how it describes the height, 1 inch shorter than twice the base, twice means 2 times, so the height is going to be twice the base, so 2 times the base, which is x, but 1 inch shorter than that. To make something shorter, you subtract. So the height is 2x minus 1 algebraically, and the base is x. So that's what the first sentence is telling us. The second sentence gives us the question, but it also gives us a piece of important information. It says the area is 60 square inches. So the area is equal to 60 square inches. We'll come back to the units in a little bit, but I wanted to emphasize the area is equal to 60. Well, a little reminder, the area of a triangle can be calculated with the formula 1/2 base times height. So what we're saying is that 1/2 base times height is 60. Let's put our definitions for the base and the height in. So we have 1/2, the base is x, the height is 2x minus 1. And that's equal to 60. Now on the left, we have a product. On the right, we have 60. We don't have 0 on the right, so we're going to need to multiply this stuff out on the left. This product is basically useless to us other than for setting up the equation. So when you're multiplying three things, always multiply the first two together first, so 1/2 x, and then take that answer and multiply it through the parentheses. So we're going to distribute this through. So we're going to get 1/2 x times 2x. 1/2 times 2 is 1, and then x times x is x squared, minus 1/2 times x times 1 is just 1/2 x, equals 60. We want 0 on one side, so move the 60 over. And now we've got a quadratic equation with 0 on one side, and we're going to need to factor the left-hand side. Now, we haven't been factoring with fractions. In fact, I don't recommend it. Instead, let's go back to a real quick trick for clearing fractions from an equation that you've probably learned in a previous class. To clear fractions, it's as simple in an equation as looking at what we have in the denominators and multiplying both sides by whatever the common denominator is. In this case, we only have one denominator, so we're going to multiply both sides by what it is, 2. Now, on the left, we're going to end up with 2x squared. When we multiply 2 by 1/2, they cancel out, so we just get minus x minus 120 equals, and the nice thing about multiplying 0 by anything is it just remains 0. So now we have a more typical trinomial, no fractions, that we can then factor. So I'm going to set up my parentheses equal to 0. I'm going to factor 2x squared to 2x and x. You can use trial and error or the AC method to factor this. I'm going to use the trial and error method here. I started with 2x and x, then I'd factor the negative 120. You could use the AC method. It's really your choice. I used the AC method the last one. It really depends on what you're comfortable with. Negative 2 times 60, negative 3 times 40. Notice these are quite a bit far apart. Negative 4 times 30, negative 5 times, let's see, 224. Helps if you have access to a calculator and word problems, so keep going if you want to use that. Negative 6 goes in 20 times. Negative 7 won't go in. Negative 8 will go in 15 times. Now, as I look at negative 8 and 15, remember I'm going to be multiplying one of my numbers by 2. 2 times 8 is 16, which is only 1 away from 15, and I want a negative 1 here in front. So I'm going to use that by putting a negative 8 in this location so it multiplies the 2x, so I get negative 16, and then I add in the inside 15x. That looks like the correct factorization. Again, you can get that same factorization using the AC method if you don't like guessing or playing around with options when you're solving. It's really your choice at this stage. I don't require you use one particular method. The main thing is you got to just be able to factor it somehow. So we now have two factorizations that when multiplied give 0, so we can set each one equal to 0. So 2x plus 15 equals 0. Or x minus 8 equals 0. Solving, we get 2x equals negative 15, x equals negative 15 halves, or x equals 8. Now, once again, it's really important to remember that x is something physical. It's the base of the triangle. You can't have a negative base. That doesn't make sense. So our only answer that's going to make sense here is the positive 8. So our result here is going to be that x is equal to 8, and 8 is the base. What were these units of this triangle in? They were in, our area was in square inches, so our base and our height are in linear inches. So our base is going to be 8 inches, and our height, if we come back up here and use the formula, will be 2 times that base minus 1, so that would be 16 minus 1, or 15. So our base is 8 inches and our height is 15 inches. Now, I've written these in kind of in a little bit of an equation here. This is an application, so we should always go ahead and write our answer in a sentence, a complete sentence that refers back to the situation. The triangle has a base of 8 inches and a height of 15 inches. One last thing on this problem. It's always a good idea to check your final result. Remember, this area formula for a triangle is 1/2 base times height. So if I wanted to double check that I've got the right area, I can take 1/2 times a base of 8 times a height of 15. You can throw that into your calculator or do it by hand. 1/2 of 8 is 4. 4 times 15 is 60. Remember, my area was 60 square inches. So that does check and make sense with the wording in the problem.